One half.
Oh crap.
Yes, you may go to the bathroom. Alright, so
I'm dead actually. I don't know if I can continue this lesson.
let's look at the derivatives of the natural log since we already practiced the expanding and condensing. I got familiar with that in case we didn't see it in pre-calc. Alright, here we go. Ready? So we're going to write down the rule. Now there's a shortcut rule specifically meant for natural log derivatives, but I'm also going to give you the general rule for any logarithm with any base. Because the natural log is a logarithm, but it has a special base of what? Of e, right? So it's like a special case for logarithms. And there's also a special rule for them, for derivatives. But the general rule still applies to it. Okay, I'm going to show you both. Today we're pretty much working with natural logs, so it won't be an issue. You can always refer back to the shortcut one. But it is good to know both. So let's say I want the derivative of ln of some function f of x. So we plug something into ln, right? And I want the derivative of this. It's actually really easy. Okay, so the rule, the shortcut rule for this one is simply the derivative of the function over the function. So it would be f prime of x over f of x. Is that pretty easy?
That's the derivative.
That's the derivative. Okay? So another way to think of it is like this. So if y is equal to ln of stuff, then y prime is equal to d stuff. Stuff. So d stands for what? Derivative. So the derivative of the stuff over the stuff. Okay, now that's where it gets tricky because what if the stuff was a fraction? Right? How do we get the derivative of a fraction? Quotient rules. Imagine doing the quotient rule for that fraction on the top and then dividing it by that whole fraction on the bottom. It's going to get pretty ugly, right? So that's why the expansion properties are good, because if I have a fraction in the argument, I can split it up using subtraction, and now I can make my life easier and find the derivative of each part and just subtract it. Or if I had the two things in there being multiplied, right, the arguments, instead of having to do the product rule for that derivative, I can split it up into addition, right, using the log, and then get the derivative of each part. So that's why the expansion rule is really cool. Okay? So that's the special rule for natural logs, but let's look for the rule for any log. So for a log with any base. Okay, so if I want the derivative of a log with something other than e as the base. Ready? What's up, Alejandro? That's weird. You should come out with an imaginary answer. Yeah. Tell her that there's a negative in that cube root, so maybe. Or maybe she mistakenly put a negative in there and it's not supposed to have one. Okay?
Thanks.
Alright. It's giving her an imaginary answer. Alright, so let's say I have log with any base, not log with a base of e like we have, right? That's an a, yes. Log base a of f of x. So here it's the same way. F prime of x over f of x, but then on the bottom you have to multiply it always by ln of the base, which is a. So why is it that this one over here does not have this ln of a part? Because it would be f of x times ln of what? What is the base of ln? ln of e, right? And what is the value of ln of e? 1. So that's why they don't put it there, but it's kind of misleading, right? Okay, so this isn't really the formula for the derivative of that log. It's really this, right? But this goes away because it's ln of e. We understand? Yes? So what if I asked you to do one of those? Let's say I say find the derivative of log base 2 of 5x squared. The formula says derivative of the stuff,
10x
so 10x divided by the stuff
squared.
times ln of the base. What's the base here? 2. ln of 2. Okay? Can we do some simplification here?
Yes.
The 10 and the 5, that becomes the 2, right? What else? This x can kill one of these, so I'm only left with 1, right? So I'm left with a 2 ultimately on the top, divided by x, ln of 2. And I put the x in the front, because sometimes when we put it back here, you think that it's together with the 2, and then you mess up. Cool? That's the derivative, right? Okay, so you can take the derivative of any log with any base, okay? When you're working with natural logs, you can just remember d stuff over stuff. Yeah? F prime over f. Do some examples? Let's do it. 6 examples and we're done. Alright, so let's get the derivative of this natural log function. What are we going to have? What's the stuff? Get its derivative. 2 over. Can we simplify or do anything? No? So we're done. That was easy. Try the next one. What's the stuff here? Alright, so let's get the derivative. 6x plus 2 over plus 2x. G stuff over stuff. Two plus the cube root of negative 14. Okay, down here, so what? I don't know if it makes a difference because they're in different modes.
Yes,
I have it in my backpack.
I think that's
I did on my own. Yeah, I know what you're talking about. Is it, wait, or is it? Number 1 is 8. No, not.
When the first verse was
Okay.
Well, not like
Wait, what?
I didn't get it. Oh, I didn't do it. I didn't do it. Yeah, but
Wow.
For that one,
I have no idea. This
This
one's in Preston test mode.
Get first.
Yeah, the cube root of negative 14 should not be in a negative number.
The last one?
What was the answer for these?
There was no, it ended up being like one part, and then everyone, like there was enough parts, but it wasn't enough, and I was like, oh, I told him, he's like, okay, we'll figure it out later.
Oh.
And now we figured it out.
Like you always walk around and do
And he was like, well, Daniela said that there was no copies, and I was like,
1
he
minus
said there's copies, and someone was talking,
theta
it's like, I
over. Yeah.
because what's the,
I didn't put it.
because I put them, those are the ones that I
I'm not surprised I got it wrong. I know I was forgetting something. Yeah, I know most of the time I was doing it.
You're like, I
No, I don't know why he's doing that.
Because they agree, if they agree, sorry.
I'll have to look at it later. Alright, try the next one. Derivative of this one. What's the stuff? What's the derivative of the stuff? Negative sine of x over cosine x. Can that be simplified? Negative tangent x. Very good. Okay. How about the next one? What would I have to do to that one? Could I rewrite it? This is ln of 2x minus 4 to the half power, right? Okay. So if I want to get the derivative of all this stuff, I would have to use chain rule, right? 1/2 times that, right, to the negative half times the derivative of the inside 2. You want to do that? Or could we make this problem a little bit easier by maybe expanding it? If I apply the properties of logarithms. So, well, if I applied the properties of logarithms, what would happen to this 1/2? It would go to the front, right? So that would make our life easier if I expanded first. Okay? So if I expanded first, my function is now going to become 1/2 ln of 2x minus 4. And now this number right here is just a constant. When I want the derivative, I'm going to get 1/2 times the derivative of this guy, which is d stuff over stuff. So what's the derivative of the stuff? 2 over the stuff. 2x minus 4. What cancels out? So we're left with 1 over 2x minus 4. So did the expanding make my life easier?
Yes.
Yes, a lot less complicated. That's why we have to practice that skill and make sure we do it. Understand? So if you can expand the problem first and then get the derivative of each part. Okay? Look at the next one. You want to get the derivative of that using the quotient rule? Or do you want to expand it and then work with it? Expand it, okay? So the divide will make it what? Subtraction. So let's expand it. We're going to get, what's going to happen with this 2? It's going to go to the front, right? So we'll have 2 ln of x minus, what's the power down here? Not 3 over 2 because it's not the whole thing to the third. It's just going to be half, right? So it'll be 1/2 ln of 2x to the third. Yes? You want to expand more and make this plus here? Or is that pretty easy to get the derivative of? That's pretty easy to get the derivative of, right? So this is where you start deciding how far I need to go. Okay? Go to the point to where it's workable. So now let's do it. Let's get the derivative. That's going to be 2 times, what's the derivative of ln of x?
1 over x.
1 over x. Very good. The derivative of x is 1 over itself. Minus 1/2 times d stuff 6x squared over 2x cubed. Can we simplify anything? This 6 and this 2 become what? 3 over 1, right? And then these 2 x's will go away, and how many will be left down here? Just 1, right? So we're done. What are we left with over here? 2 over x, right? Minus 3 over 2x. And that's pretty good to work with, but later on when we start having to find where the function has vertical tangent lines and horizontal tangent lines, we want it to be a single fraction to be able to work with it. So let's go one step further and make it a single fraction. Are we okay, or did I lose some of you? You're okay? You sure? Okay, so what would be my common denominator? Just 2x, right? I can make this guy a 2x really quick by just doing what? Multiplying by 2, right? So what's 2 times 2? 4 minus 3. What's 4 minus 3? 1. So it becomes 1 over 2x, and that's my derivative. Easy? Yeah, it became a lot easier to do when I rewrote the problem, when I expanded. So make sure you know how to do that. The last one. What's the derivative of ln of x? Derivative of x, 1 over itself. One to make sure that you know. If you don't know, you know how to find it, okay? Derivative of the natural logs is derivative of the stuff over the stuff, right? F prime over F, whatever F would be, which is inside. Remember that if I can expand it first, I should expand it first to make my life easier. Instead of having to do quotient rule, and then after I do quotient rule, divide it by that, right? That would be crazy. You'll still get the same answer, okay? But it will be a lot messier. You understand? Okay? So this is one of the applications of knowing the properties of logs. Right. Make sure you know the general rule for the derivative of any log with any base, right? Okay, so it's the same thing, d stuff over stuff times ln of the base, okay? Got it? Awesome. So your assignment is to continue working on the rest of the problems, which is numbers 10 through 17. Okay, that's your assignment for tonight. Sounds good? All right.
Axel, just a record, you hear what I